Hey there, this is Nick at opennet.io, and tonight I want to show you about a little breakthrough we just had with a new configuration with our routers that basically allows to have a single SSID for the access point level of our routers that is shared among all nodes in the network, and therefore a client will only have to join the network once, and it'll roam seamlessly around the entire network without any issues with DHCP or having to wait for a new lease or not working at all because it didn't realize that it actually needed a new lease, as was previously the case. We achieved this by having two different routers, a configuration that we already had before anyway because it maximizes the bandwidth. So one router is the mesh router, and it basically handles all the backhaul aspect of our network, so the actual mesh aspect. So it's a router that connects with all the other mesh routers in the network, has nothing to do with clients, it just does that. And then on the LAN port of these mesh routers, we have access point routers, we call them. So they're simple routers that do a very simple routing function, just like any standard router. And on their WAN side, of course, they have the mesh router, and they simply have a simple Wi-Fi network which shares the actual connectivity of the mesh network with the clients. Now, this maximizes bandwidth so that because every router can do its own job. One router does the mesh level, and the other one does the access point level. And it also allows us to do some cool stuff like advanced routing, or really being able to identify issues in our setup and streamlining the entire configuration. Now tonight we've thought of a new thing, and the idea was, instead of just having it do an access point level, transparent access point, simple access point, dumb access point, call it however you want, we have all the access point level routers do also a simple routing function, all of them with the same IP address, with the same subnet mask and everything else, so that they will all have the exact same configuration. And when a client roams between them, the DHCP lease it had from the previous access point, it will be already valid with the new one. It wouldn't even actually notice, as far as we can tell, that this is not a traditional network with a centralized router and a lot of access points just transparently broadcasting the network over Wi-Fi. It'll probably think this is exactly the same setup, not knowing that there's actually a bunch of different routers and that every node has its different router, even though, in fact, it has the exact same configuration. We've tried this, and it works very well. I'll show you later in a little field test we set up. So basically, this is our setup. We have, this is not actually OpenNet. This is a mesh network with the exact same configuration that I'm doing for a volunteering organization. And we have 3 routers spread around the station here. We're going to only see 2 of them tonight because the third one is in a room which we can't access, so we weren't able to install the new access point router. So this is the first one. You can see that it's meshing with other 2 routers. And basically, this is the other one. And these 2 instead are the new access point level routers we set up. So this one is connected to this router here, physically with Ethernet, and this access point level router is connected to this mesh router. The 2 mesh routers are TP-Link's 1043 NDs, if I'm not mistaken, and the access point level routers are just some very small, very cute, actually, NEX WT3020 mini routers. They work really well in our experience, but in this case, it's just for a test. It's not the actual final configuration. So the access point routers are just fresh out of the box with the subnetwork that we are going to assign to all access point level routers, which is 10.0.0.1. And on the WAN side, they'll have a static IP address, which is the IP address of the mesh router it's connected to incremented by 1. So if, in this case, our mesh router is 10.250.2.1, it's going to be 10.250.2.2, also because the DHCP range for mesh routers in our configuration starts at 10. So we have about 9, actually we have exactly 9 IP addresses to hand out to access points in case one mesh router were to have multiple access point level routers. So just make sure on the WAN side you configure it with the right details, so the right broadcast and everything else, and you're good to go. On the Wi-Fi side, we just have the very simple access point mode Wi-Fi network, and this is basically it. Now, of course, we have the access point SSID disabled on the mesh routers because they're only doing the backhaul. Actually, you can see this network here, which is the old one, before we actually split the functionality between two different machines. So let's go out on a little field test and see how it works. Okay, so just to give you an idea, this is our ISP ADSL router, and it goes up to our TP-Link, which is the mesh router in this case, and this little next guy is the access point level router we were talking about just a second ago. Now we have the exact same setup in another room. So let me just give you an idea of how far away it is. It's a perfect distance, in my experience, to have my phone, which is the test client in this case, roam between access points when it's at about 60% signal strength, according to an app called Ping Tools Pro, which does very simple Wi-Fi diagnostics. So same setup over here. No WAN in this case, because this router is meshing with the other router we saw just before, which has uplink to the internet, and our access point level router. Now, let me show you the Ping Tools Pro app and see what I mean. Okay, so now my phone is connected to the Wi-Fi network that is broadcasted from all the access point level routers in this network. So in this case, just these two that we've installed tonight, and it'll become 3 in the future. But as you can see, the signal strength is about 80% because I'm really close to one of the two. And just to give you an idea of how quickly the handoff roaming event is, I'm gonna ping our ISP router. Don't be fooled, the 10.0.1.1 IP address is the ISP level router in comparison to 10.0.0.1, which is our access point level router that we just installed. This is a wrong configuration. All ISP level routers should have 192.168.0.1 IP address in our setups, but we haven't had time to update this yet with all the devices on the local network. So just keep this in mind. This is the ISP level router, the ISP router that we're going to be pinging. So let me start a ping, and I'm going to go back to the signal strength indicator and walk towards the other room. As you can see, the signal strength is going to drop considerably. When it reaches about 50 or 30%, my experience right here, my phone is going to roam to the other access point rather seamlessly. Sometimes it shows 0% signal strength for a second. Other times it just goes up to 100 without even passing by 0. I guess it's just an aesthetic difference, but in any event, give it a second here to roam. As you can see, it just roamed here. And if we go in our ping section, you can see that it only missed one ping right here when we roamed over to the other access point. Now, sometimes it doesn't even do that, and you don't even see one lost packet because it's just so quick. And that is, in my experience, the same level of quality we have in traditional infrastructure networks. The school where I work in, for instance, has 45 access points and a centralized router. And in my experience, whenever I'm between rooms, I get between 0 and 1 lost packet. So this is a fairly decent result, in our opinion. Again, I'll walk back towards the other room and show you that this is a consistent result. Again, this is the perfect distance to test out on because my phone perfectly roams between the two. If we go back to ping now, you'll see that the only lost packet was this one here. So that's it for now. I think this is a setup that we're going to be using in the actual OpenNet project all over the place. And if every node can be split into routers in a cost-effective way, this is really the best way to go, I think. And we'll keep you updated on the results if we have anything else that we think is interesting to share. Let us know what you think, as always, and thanks.